New Zealand. We are not the biggest country in the world in terms of economy, size, or population, but in my opinion, we have the potential to be one of the most innovative. Our country, as we know it, is unique. Our vast amount of clean air, fresh water, vast and untouched lands give and facilitate the rise of goods and products which are by no means new or inventive to society, but can only be produced at a quality which is signature to that of New Zealand. It is no surprising that a majority of our export economy relies upon the delivery of these products to overseas entities and investors. Our 5 primary industries of agriculture, forestry, fisheries, energy and mining, and horticulture are not only important to our economy overall, but also to our cultural identity as New Zealanders. Combined, these 5 sectors contribute to 50% of New Zealand's total exports. Due to New Zealand's place in the Trans-Pacific Partnership Agreement, demand for these products is expected to increase steadily over the next 15 to 25 years. However, this is also the problem. Recent government statistics have shown that across all our 5 primary sectors, there is currently a skills and labour shortage being faced, which shows no signs of alleviating in the immediate future. So with demand for our products only increasing and us not having the capacity to meet that demand, our primary industries face stagnancy. In order to ensure that our primary industries and therefore our economy is sustainable for the long-term future, I believe change must be made, and change requires innovation. New Zealand has a long and spirited history of developing unique, innovative and inventive processes, and it is in the spirit of this that I propose we take our primary industries into the future in the form of unmanned robotic technology. So what is an unmanned robot? Well, an unmanned robot is essentially a machine or vehicle which can operate without the direct presence of a human operator. Broadly speaking, there are 2 main types. Autonomously controlled URs can operate Autonomously controlled URs can operate with 0 to minimal input from a human operator, and remote controlled URs can be controlled from a remote module from a remote human operator. Broadly speaking, there are 5 main components that compose of an unmanned robot. A power source, which can either be electric or petroleum-based, a motor which converts potential energy in the power source to workable mechanical energy, sensors which take information from the external environment of the robot and feed it back into the CPU, which serves as a central processing unit and is essentially the brain and contains all of the core programming, logic, functions, and instructions. Lastly, every typical URV will compose of moving parts which can be either rotors, wheels, or mechanical manipulators, depending on the robot's intended function. So just how can these unmanned robots benefit our primary industries and therefore our economy as a whole? Let's look at agriculture, for example. The agriculture industry is New Zealand's premier industry in terms of generating total exported revenue. It also suffers from severe skills and worker shortages and is in dire need of innovative processes, increased efficiency, better optimization, and more precise decision making. If an unmanned robot can be designed, programmed, and implemented for the purpose of conducting menial, time-consuming, and labor-intensive tasks, such as the watering rows of crops, automated milking, or meat packing and delivering, then we can greatly reduce the work pressure on an industry which is already struggling to source workers. Simultaneously, aerial drones can provide farm managers with important information on crop health, density, water levels, animal movement at a far quicker time and at a far lower cost than it would take using normal methods. The forestry industry suffers from similar issues to the agriculture industry, with the main concern being that of safety to its workers. If an unmanned robot can be designed, programmed, and outfitted for the purpose of cutting down trees and collecting logs, especially for that on steep terrain, then this can not only alleviate pressure on an industry that is also struggling to source workers, but also greatly increase worker safety in the workplace. Simultaneously, aerial drones can provide forestry managers with important and vital information on biosecurity, potential forest fires, and tree health at a much quicker time and at a much faster pace and lower cost than that using current methods. The energy and mining sector is a frontier sector in New Zealand, with our country containing vast deposits of natural resources. Surveillance drones equipped for the purpose of geophysical surveillance can be used to detect and isolate these pockets of resources. They can also be used to survey large kilometres of pipelines and energy-carrying infrastructure. Exploration drones can enter newly drilled sites and assess for hazardous conditions, such as that of rough ground or elevated methane levels, without the need to risk a direct human operator. Remote-controlled robotic vehicles can handle dangerous operations such as that of chemical spillages or dangerous wastes without the need to, once again, risk a direct human operator. Lastly, AI-controlled unmanned robots can ferry large amounts of deposit guided by GPS and can carry either personnel, equipment, materials, or waste through kilometres and large sections of mine infrastructure, and potentially even narrow and confined tunnels. Of course, these unmanned robots are not simply limited to use in our primary industries. With uses like military, environmental research, manufacturing, construction and surveying, and search and rescue, I believe they have a further part to play in our future society. I end my presentation on this note. The world is moving into the future. New Zealand will eventually move into the future. The question is, how fast do you want us to reach that?